Well, hey, welcome to Module 1 of Network Defense Essentials. And in Module 1, we're going to talk about network security fundamentals. When you are on the job, you want to make sure your network is secure as possible. And so we want to talk about some of the terminology, kind of an overview. So in this module, we won't be going into great depth on everything because guess what? We have a number of modules that are going to take some of the topics that we talk about in this module and take them into great depth. So we'll be doing that. So let's jump on in to the topics, the objectives of this module. Number 1 is to understand network defense. Number 2 is to understand information assurance principles. Number 3 is to understand the benefits and challenges of network defense. Number 4, we're going to look at an overview of the different types of network defense approaches. Number 5, we're going to understand the different types of security controls. And number 6 is we're going to look at network security protocols. Let's do it. Starting with number 1, we're going to look at understanding the fundamentals of network security. And then after that, we'll look at some of the security protocols. So what we want is a network. Let's just zoom out here. Okay, let's just zoom out and give you kind of the overview of what we're talking about. So what I'd like you to do is come for a walk with me into a building. And it's not quite at the city center. It's a little bit off, and it's a 8-story building. And what we're going to do, I want you to walk with me into this building. And here at the front desk, we're going to need to give you a visitor's badge. So go ahead and clip that on somewhere. All right, good. And you see the lobby here. I want you to stop and look at this lobby and just look around for anything electronic. All right, so you see the receptionist that helped you with the badge. Well, she has a really nice little computer system, right? I want you to also look around. Look around you. Look up in your imaginary lobby, and you'll see at least one security camera. I want you to look over there by that window. You'll see that in the plenum, there's an embedded device. You know what that is? That's a glass break detector. So if after hours someone breaks the glass, there'll be a signal sent. This is part of their IoT network. So we have a desktop computer for the receptionist. We have a camera. What else do we have? Do you see this display? That is a moving display that's showing some of the projects that the company is working on. It's like this big flat screen monitor turned on its side. Well, that can be controlled from within the organization, and it's also an IoT device. Well, since you have your visitor's badge and you've signed in, let's go ahead to one of the busiest floors as possible. So this company, XYZ Corp, I tell you what, they do a lot of business. And since they do multi-hundred millions of US dollars in business, they have a lot of people calling in the organization saying, hey, I need some help with something I ordered. So if we go over here to the 3rd floor, let's get out of the elevator, you'll see there are all these cubicles and people are on the phone. What I want you to do is let's walk up to one of these cubicles and I want you to look at what's on the screen. So it's a small desktop computer, and on the screen is an application. And this application allows them to fill in the customer details, do a search for customers, create new customers. And everybody in this floor, it's kind of noisy in here because everyone has a little device where they answer the phone, and they're measured on the number of phone calls an hour they get. And so for our customer support team, they need the ability to get those phone calls managed, and that's it. And then they finish their day, they clock out, and they're headed home. Now, let's go up to the 8th floor, and here we have our executive suites. Notice how this conference room looks really nice? Well, this conference room has Wi-Fi in it. In fact, I don't know if you noticed, but there's Wi-Fi on every floor. Not only is there Wi-Fi on every floor, but in all the executive offices, some of them have laptops, some of them have laptops and desktops. Some of them have tablets and they all have tablets and phones, in fact. And this executive conference room is wired. In other words, there are Cat6 or Cat5e connectors on the wall so that people can plug their laptops, desktops, or whatever they bring in. There's Wi-Fi, there's guest Wi-Fi, and there's corporate Wi-Fi for XYZ Corp in this conference room. Now, let's go down to the third floor. On the third floor of XYZ Corp, this is where we have our dev team. These are the people who are the brains of the operation. These are the people that are bringing in, creating the apps that bring in multiple hundreds of million dollars of cash. These are people that are programming in everything from Python to C++, to C#, and they're doing a lot of scripting, and they're putting together the website. So these people have different needs than the people in customer support. So when they come in the morning and log into their workstations have a lot more capability. They don't just have one single app like in customer support. What they have is a full array of entire operating systems, and they have access to web servers like IIS and Apache, and operating systems like Windows 10 and Windows Server and Linux and BSD, and they have even other operating systems that they program for. They also follow a secure coding methodology to make sure that every line of code that leaves into the production network is secure. And so they have a very different way of going about doing their work on a daily basis. Sometimes they will program from home. Sometimes they'll program while they're on vacation. They're the only one on the beach with a laptop programming away on a project. And so they have a lot of different needs from the people on the first floor, which is you and me, right? The IT people. These are the IT, the security people. These are the people that take care of the network. They take care of the network security. They have the most powerful accounts in the organization. They can get into every nook and cranny of every section of the network. The network engineers have access to the plenum into closets where routers and switches are stored. They're the ones who contract out and use internal work resources to wire new network connections, network drops, to control the virtual local area networks or VLANs that are in customer support, in the dev team, in the executive team, and in IT, and in sales. They control the entire network. They control the entire identity, the entire encryption. And we have a team of people dedicated for looking for intrusions into the network, looking for oddities into the network, looking for deviations in employee functionality. Like, for instance, Fred, who's in customer support, comes in at 8, leaves at 5, logs in at 8, logs out at 5 every day. We know that he has a certain behavior, but guess what? Fred's been trying to log in from another workstation, but Fred is logging in from the Ukraine, right? There's something out of bounds here, and the people on the first floor, you and me, are going to notice that, and we're going to find out that somebody's trying to hack Fred's account. So what we have is a multi-story building, part of a large organization that has products, accountants, customer support, executives, IT people, network security people, sales teams, all wired and wirelessly, consuming, using, processing information in a network, right? That is what we're looking at. It can be bigger than I've described. It could be smaller, like in a 10-person office, or even in a 1-person office where somebody's just trying to keep that network as secure as possible for their small organization. But I want you to imagine throughout this class that you are defending, working with a real network, real cubicles, real people logging in, and real action taking place on a day-to-day basis on this network. So when I talk about terminology, you'll often hear me refer back to XYZ Corp and what they're doing with their network, because I want you to be able to sort of imagine what we're talking about in the context of reality, right? Not just terminology, but some organization, some group of people working together as a team to defend the network. So now with that vignette, that thought bubble in mind, let's look at the essentials of network security, right? So what we want to do is we want to provide network security controls. Whenever you see that term, security controls, what we're talking about is making sure that only the correct people have access to the correct resources. Have you ever logged in? Control-Alt-Delete, username and password? That's a security control. Have you ever taken your phone and it had to read your facial geometry or whatever? That is a security control. Anything that stands between an entity, and when I say the term entity, that could be me, a user, could be a program or protocol, anything that requires access. Could be computer generated, or it can be biologically generated. As it turns out, that's me, right? And anything that stands between that entity gaining access to a resource is a control, right? So that's a network security control. Then we have network security protocols. The term protocol is a term that is talking about communicating, right? So if I were to start talking in another language, like Espanol or Le Français or some other language, or Mandarin or something like that, if you spoke Mandarin or French or Spanish, we'd still be able to communicate, but others wouldn't understand if they didn't speak that language, right? And so the idea of a control is, I'm sorry, not a control, but a protocol is where somebody is able to speak the language. In this case, it's computers. The computer can communicate with another computer. If they don't speak the same protocol, though, then they won't be able to communicate. We'll look at the protocols of communication in a little while. And then the next one we look at is network security devices. There are a variety of devices that we can use to secure the network. And those devices range from small security devices that are at the edge, or larger, maybe larger security devices like firewalls and IDSs, intrusion detection systems, IPSs, intrusion prevention systems, at the edge of the firewall, all the way to devices and programs in the interior of the network. We'll talk about those, all right? So those are the three major areas. The goal of network defense is to protect the organization's information. It could be their entire website, their databases, user information, customer information that we're trying to protect. Protect from what? Unauthorized access, misuse modification, service denial. We don't want to get blocked from getting to our information, or even a degradation, slowdown, or disruption of the service. That's what we're trying to do with network defense. And so we have information assurance principles that help us with what's called defense in depth. So if we go to XYZ Corp on every single floor, from the receptionist to the IT department, all the way up to the executive department in XYZ Corp, what we're trying to do is make sure that every area has been thought about, has been put into a plan to defend against attacks. Next, IA, those principles are enablers for that organization's security activities. We want to protect, we want to defend the organization from security attacks. All right, so let's look at the IA, Information Assurance Principles. Those are confidentiality, availability, and integrity. There are a couple more we're going to look at besides these, but let's start with confidentiality. One of the things I want you to think about with the term confidentiality, and another thing we're going to think about with the term integrity. So confidentiality, line that up with encryption, right? We don't want any unauthorized information disclosed with confidentiality. And one of the ways we do that, if you hear we have an authorized user in a server that they're trying to communicate with, we don't want this guy, the man in the middle attack, to find information or even be able to start the attack. And that is why we have encryption. When you think of integrity, think of things like digital certificates and hashes, mainly digital certificates. And what we want to do with integrity is make sure that, see this user over here? When he sends something over to the other end of that communication, we want to make sure it has not been changed. I don't care if it's a 5-bit communication, just 5 bits. I don't care if it's 50 billion bits, 50 gigabits. I don't want one or 0 in that communication changed. And if it hasn't changed, then I have good integrity, right? I don't want it modified. I don't want it tampered with. That's integrity. We have availability, irrespective of any of the other IA principles that we put into place. I want to make sure that that information is available to whom? Authorized parties, people who should actually be able to look at that information, right? I want it to be available. In other words, when I log in, if I use two-factor authentication or multi-factor authentication, when I log in, I want to be able to see my stuff. That's simple, right? So a couple of other things we want to look at then is non-repudiation and authentication. So let's say that I'm an employee with a temper. Maybe I should have been fired a long time ago. Maybe so. Because I'm driving into the office, jamming out on some good music, and I see another employee driving into the driveway, but they're slow and sluggish. I'm a great driver, so I pull in front of them, and they almost hit me because they were expecting someone to pull in front of them. Oh, and it makes me mad. I can't believe you almost hit my super expensive, tricked out car. I can't believe that, even though, of course, I'm the one who ran in front of you, but let's just ignore that. And I get really mad, really, that temper of this employee, really mad. And so when I get to my desk, I fire off an email that says, I'm going to get you after work. Just look out. And then I leave my workstation and I go to another location in the company, and I'm working in the shop floor or somewhere else. And hey, weird, there's some people walking towards me. It's human resources, a security guard, my boss. Oh man, things are going to get bad here. And they say, did you send an email message to Fred saying that you were going to get him after work? And I said, no, not me. I've been here the whole time, right here. In fact, look at it on my phone. You can check my phone. There's no evidence of me sending a message. With non-repudiation, though, I'm going to be in big trouble. Because with non-repudiation, what it turns out is that every single aspect of the security of that communication I did from my desktop computer was associated and could only irrevocably be associated with me and my account. So there's no doubt that I did it. I guess I'm going to have to deal with that security guard. Anyway, that's non-repudiation. It ensures that a party in communication can't deny sending the message. And then the last one we look at is authentication. And authentication, what we want to answer this question is, who are you? Who are you? So when an entity logs in to an identification system, they get authenticated, verified as being the resource, being the user, being the entity who they say they are, right? This is nice to authenticate because then you can block attacks. There's another type of authentication called open authentication. We'll look at this when we get to wireless, that allows anybody to connect to a resource. And this would really allow an attacker access. But in our case, we're going to use more sophisticated authentication. So those are some of the information assurance principles. There are a lot of benefits to network defense. We protect assets. Now, in every one of my classes, what I tell my students to do, see this term here, assets, see those two S's in assets? Turn them into dollar signs, because we are spelling assets with dollar signs. Why? Because all assets are rated, R-A-T-E-D, rated by how important they are to the organization. And so an asset is going to be measured in dollar signs, right? We'll talk about that when we get a little bit deeper into the organization. We want to protect our assets. We want to comply with government and industry-specific regulations. Like, for instance, let's say that you are a medical-related company. There's a regulation of HIPAA. Let's say that you are an organization that deals with customer credit cards. We have PCI, DSS, and there are many other compliance issues to deal with. Network defense helps us to comply with those regulations. It helps to ensure communications with our clients and suppliers, with resources, people communicating with each other. It helps to reduce the risk of being attacked. We really want to do that in this era, and to gain a competitive edge over a competitor by providing more secure services. So if our services are more secure than the competitor, that just might give us more annual revenue, AR, right? Because in the comparison between multiple organizations, if a potential customer looks at my organization and says, wow, XYZ Corp, those guys know what they're doing. And I'd rather log in and create an account and put a credit card into there than with the people at PDQ Corp. And so, yeah, I could gain a competitive advantage. There are also some challenges. These are the things where we come in to help facilitate. These are the network defense challenges. Number one is a distributed computing environment. I'll tell you what, it's complex. You know how I was taking you on that imaginary tour of XYZ Corp, all the different floors, and they have a data center, and they have IT department, and they have customer support. I took you on that entire tour. The part of the tour I didn't take you on is one that's difficult to do, because XYZ Corp subscribes to quite a lot of services in the cloud, in Azure. And as doing so, there are a lot of the workloads of the organization that you can't see just by looking around at desktops, because they're in the cloud. They're in data centers in different locations. And so what we're saying is organizations can be vast. They can be complex, multi-layered in so many different ways we haven't even started to get into, from containerized applications to the where we can virtualize our network functions, virtualize our network edge, where we can have ubiquitous security with zero trust networks. There's so many complexities, and as it turns out, there are a lot of vulnerabilities that attackers want to take advantage of. And so with these environments that not only have desktops, but have virtual desktops, not only have servers, but have virtual servers, not only have virtual servers, but have cloud services and cloud workloads and containerized and virtualized functions, tell you what, it's complex. When you get that job in security, every organization is just a little bit different, and you have to learn to roll with the complexity of the environment in which you are working. The next one is emerging threats. These are potential threats, things we didn't see coming. They're getting more and more sophisticated. They're getting better organized. Did you know that most hacking, in terms of attacks from threat actors, most of these attacks from threat actors come from organizations that are crime organizations, that are like crime corporations, that are every bit as sophisticated as the large corporations you see around you, but they're dedicated to one thing: crime. They're sophisticated crime organizations. That's part of our emerging threats, coming up with innovative new ways to steal, kill your network, and destroy your data. Next, we look at the lack of network security skills. And hey, that's why you're here, to gain more skills. So organizations are failing to defend themselves against those rapidly increasing threats due to the lack of security skills. And that's one area that there needs to be a constant budget item in all organizations, is to constantly educate employees in the same way you're doing now. Because what happens is everybody from the people who are just answering phones, to the people on the executive suite, to the people who are in the dev team, they need to know the types of emerging attacks that are happening against networks, including their network and all over the world. So there are types of network defense approaches. Number one, and this is the one I really, really like, and it's harder to measure though, which is preventative. So you have methods that are used to avoid. We avoid the threat, so it never happens to us, right? Number two is reactive. And this is a method that's used to detect the attack on the network. It already happened, but guess what? We detected it. And in reactive approaches, the speed of reaction is what counts. We'll talk more about that in this course a little bit later. The next one we have is retrospective approaches. And this is where we look at our causes for attack. We remediate the attack. We go ahead and eradicate, remove it. We'll talk more about what all these terms mean, and then recover from the damages. So we had an attack. We didn't react quick enough. It did some type of damage, and now we're putting things back together. The next one we have is proactive. I like that. I like preventative, and I like proactive. So what these are is we make decisions that help us to prevent attacks in the future. This is where we're casting our vision into the future and learning about emerging threats, possibilities, defending against those before they happen. That's the way to go right there, in my opinion. So there are controls, network security controls. In specific, we talk about here are administrative security controls. And so this is looking at managing administrative access controls. What are we doing? What are we doing? We're looking at ensuring the safety of the organization. Here's some examples of network administration security controls. Number one, regulatory framework compliance. So I was talking about being involved in medical stuff, medical transactions. Maybe you're a clinic and you have a couple of doctors. Maybe you're a big hospital. Either way, there's an entire framework in HIPAA to help with compliance. And so what we do to protect patient data, et cetera, is we put together the appropriate, guess what? Security controls. Number two, security policy. Here is an area that is extremely important. We look at policy and we think, oh, policy, that's boring. That's a bunch of paperwork. But in reality, policy is what makes all of the security controls and the network protection possible. Imagine this. There's a new policy that says that your length of password, so we go up to the top floor where the executives are, and there's a meeting with some of the people in the IT department, and they have some people in the dev team up in that conference room I was talking about, and they decide that the password for XYZ Corp needs to be 20 characters. So with the password and XYZ Corp needing to be 20 characters, that creates a new line that's been edited in the password policy of XYZ Corp. And that starts to percolate down through the entire organization. from the users who are encouraged and trained to use passphrases that are easy to remember, to the IoT devices, to the networking infrastructure devices like routers and switches. It percolates through everything because there was a change made to a policy in a conference room, and this can help avoid an attack in the future. So security policy is actually pretty important. Creating it, maintaining it, and innovatively working with it. Number 3 is employee monitoring and supervising. Very important as an administrative security control. We really need to know what's going on. Remember that example I gave you of that worker who comes in at 8, leaves at 5, but for some reason he's logging in over and over and over again, and he's trying to at 3 a.m., right? Because we've monitored and supervised and we know what's going on with our employees, we know that's outside of the bounds and there is a problem. And number 4 is information classification. Have you ever worked in a environment where there's classified information? If you've worked in government or if you've worked in the military, irrespective of what country you've been in, there are classifications. Like for instance, secret, top secret, or in the Department of Defense, and the Department of Energy, it would be like Q and other classifications. Why do governments do that? Why? Because we want to know, we want to make it clear how to handle this information. And it's not just in government or military. We need to do this in our normal organizations to make sure that we know how to handle different stratas of information. So that actually turns out to be important for all of us, not just for government or military. And then the last one we have here, number 5, is security awareness and training. This is what you are doing right now. Getting informed about computer, network, and other types of security. But it's not just in classes like this. You take this and you go back to your organization and train others in certain aspects of a class like this so that they can know too. We have train the trainer. We have information flowing down through the entire organization. We have briefings, heads up. Did you know that in a company that just like XYZ Corp, that there was this type of attack that involved an email being sent to an employee that looks like this? Don't be caught trying to click on a link in an email like this. We train employees, make them aware of what is going on. All right, so if you look at network security controls, one of the most important security controls is actually this, physical security controls. We've talked a little bit about this already, but these are, again, measures to prevent unauthorized access, but to what? Not to the network, not to the application, but to physical devices. Have you ever seen a lock? Me either. It's kind of a weird thing. No, we've all seen locks and fences and badging systems. In fact, just to get into this building, I had to have a badge, right? Security guards. Have you ever dealt with security guards who maybe want to check your badge, maybe want to make sure that you are supposed to be in that area? I've been in areas before where I shouldn't have been. I remember when I was very young, being on a military base in the wrong place. And the MPs, they found us and told us we needed to go back in through a different gate. We have man-trap doors where you are in between 2 doors. You go into one door and it locks, maybe. And before you can get to the next door, there's somebody who can see who you are, right? Biometric systems, that's anything having to do with your your physical body, right? So that could be your fingerprints, it could be your iris pattern, could be your retina, things like that. Lighting is a physical security control. If you have a parking lot that is 100% dark at night, there are going to be people who would like to hang out there that you probably don't want to meet that evening. And so if you have lighting, they kind of scurry away. It's actually a physical control. Motion detectors, making sure we know who's in a room or who's in an area. A closed circuit TV where we can record. what's going on. Alarms. If you hit the door or you try to open the car. One of my favorite alarm systems is Tesla. You know, the electric car, they have like a security mode system where it's called Sentry mode. And it records, it does all kinds of stuff. It's very interesting. You might want to look up Tesla Sentry mode. But it's an alarm among many other things. So these are some of the physical security controls. Now, let's look at technical security controls. What in the world is a technical security controls? It's a set of security measures that are taken to protect a system from unauthorized personnel. So it's look at this term right here, set. So a technical security control isn't necessarily just one thing, it's a group of things. So for instance, first of all, I have to go through an access control. All right, now you need to authenticate and authorize. And while you're there, we're going to audit. Make sure we know who logged in, when they logged out, what application they used, how long they were there. If it failed, if it was a success, we're going to also see what protocols are in use in terms of security protocols. But we're also going to take all that signal and we're going to move it through a network security device, like a firewall, like an intrusion detection system, IDS, or an intrusion prevention system, IPS. So that's what we're doing with security controls. And the salient, the most important focus word on this is it is a set of security measures for controlling, protecting resources from unauthorized personnel. All right, that brings us to looking at network security protocols. So we looked at some of the fundamentals of network security. Now let's look at some protocols. Oh, look at all these protocols. Radius, TACAX+, Kerberos, PGP, SMIME, Secure HTTP, HTTPS, TLS, SSL, IPsec, and a partridge and a pear tree. There's just so much stuff here. It's crazy. Radius, which is a remote authentication dial-in user service, has actually been around quite a long time. It's part of AAA. AAA is authentication, authorization, and accounting. Do you remember dial-in? Yeah, you're probably too young, right? Dial-in is when you had a modem, and that's how you got on the internet through your telephone line. And we go, make all kinds of noises, and then get you dialed in. And you'd be using a network like Prodigy way back in the 80s and 90s, or like AOL back in the 80s or 90s. And back in those days, when you signed up for one of those internet services, one of the cool things they would do is they would give you a local dial-in number. It could be that the internet service, the organization was actually run in California or New York or Florida, but you dialed in with a local number. And not only did you dial in with a local number, but the AAA related information was also cached locally so that when you used your local number, you used a remote authentication. Look at that. See the term? Dial-in user service, and it authenticated you. What did it do? It centralized your authentication. So I put in my username and password, all excited about getting on the internet for the first time. And it looked at my authentication, and based upon that, it gave me authorization. Authorization is what level of access do you have? And not only that, but it went ahead and put a little date time stamp about when I logged in and from what location and so on, and did AAA, authentication, authorization, and accounting. So that's what Radius does. And yeah, I know it says dial-in. Why is it that we would be talking about this super old service? Well, because it's so useful even outside of the old dial-in stuff. Like for instance, let's say that there is a Wi-Fi connection, and rather than authenticating to the wireless access point, the wireless access point can say, hey, Radius server, why don't you do the authentication? Right? So it can provide authentication for switches, Wi-Fi, routers, etc. centralizing that so that I can log in to using my network, my organization's network password and username and whatever factors of authentication I use. So it initiates a connection, sends an access request. If you actually are scanning this, you'll see it says access request to the server. And then the server receives a request, looks for the credentials in the stored database, and it does an access accept, if it accepts it, along with the access challenge, or it could send an access reject based upon what's going on with this handshake. So that little accounting dash request also can be set for more information. And so that's some of the communication. So what we'll be looking at over the next series of slides is some of these handshakes. We're not going to go into huge depth in them, but just an overview. So we have the access request. That's going to be that username and password. It's going to be hashed among other, there are many other ways you can tune it. There's going to be access accept, access reject based upon what credentials are put in. And there's going to be that optional access challenge depending on what else you want your Radius server to do. So that's what your Radius server is going to be doing. It has accounting. It sends an accounting request looking for information for a connection that was already accepted. And then once the request is sent in, there's going to be a response, and there's going to be a status that's sent in. And then the end, there's going to be an accounting response message that'll have successful establishment of the network. So with these types of devices, in fact, almost everything you do with computer devices, whether you're using your phone, a tablet, a laptop, a desktop, if you ever establish communication with something, you open up Gmail on your phone, you log into your phone, you get into a Wi-Fi network, you are in an office and you plug a wired device into the wired network, you click on a link to take you to a website that's running HTTPS. In all of those situations, there's a series of exchange that goes by very quickly. But in the last module, we'll be looking at how you can monitor that. And you can see an exchange like this happening on a Radius server. The next type of server is TACACS Plus. So let's go back to the past again and talk about Radius. So Radius was put together to help authenticate people on those old dial-in networks. There was a company called Cisco. In fact, there still is. They're a giant, amazing technology company. And they looked at Radius and they said, you know, that's not good enough for what I want to do with my routers and switches, Cisco said. And so they created a protocol called Terminal Access Controller, Access Control System. And then in looking at their Terminal Access Controller, Access Control System protocol, they said, you know what? That also isn't good enough. So very quickly on the heels of creating TACACS, they upgraded it to TACACS Plus, which is Terminal Access Controller, Access Control System Plus. Say that 10 times real fast, I'm telling you. So TACACS Plus was created by Cisco to help bring AAA, authentication, authorization, and accounting, to Cisco's networking devices and do so better than Radius, because built in to TACACS Plus AAA is encryption. Encrypting not just the core of the transaction, but the entire communication between the client and the server, including their user's password, protecting it from attacks. And that is what Cisco wanted, is to protect that. So in fact, this is actually a really good illustration here. This little icon here is a Cisco switch, right? And what you could, I said Cisco switch. This is actually a Cisco router. Switches look a lot different. If you look at this client, what they're doing is they receive there's a client receives a resource request from the user, and we're assuming authentication is already taking place. The request, it's not sent to this device. It's not sent to the router. Instead, it's sent to another server that will actually review the request, respond with the AAA information, pass or fail. Yep, that was a good password, good username, go ahead, let them in. Or that was a bad password, bad username, you are rejected, right? And then it grants or denies access, and then, only then, do you gain access to the device and to the network into which it connects. And that way, when you have a TACACS Plus server, just like you see here with a TACACS Plus security server, in their actual corporate network, where you have things like Active Directory running, you can share a subset of the user information with the TACACS security server, allowing the remote user through a public network and a TACACS Plus client to gain access to the interior using their own corporate username and password. So it's actually pretty cool stuff. Let's look at another protocol, Kerberos. Kerberos, if you look at the history, I mean, all of these things have such amazing history. Kerberos actually comes from the term itself comes from Cerberus. Cerberus is the dog in this historical fiction context that guards the gateway to Hades, right? That's what Cerberus is. So if you want a multi-headed, like really mean-looking dog guarding your network, that's where Kerberos comes from. And back in the late 90s, Kerberos was already around, being adapted for multiple Linux networks, Unix networks. And Microsoft brought that into Windows Server 2000 with Active Directory to guard not the gateway to Hades, but to your network, to your information. And so what happens is there is it's actually called KAP in many cases, the Kerberos Authentication Protocol. And what happens with the Kerberos Authentication Protocol is we have several things going on here. Number one, we have an entity, a user usually with credentials, and that credential is going to go to the authentication server. Now, when we look at the AS, or authentication server, and we look at the ticket granting ticket service, or TGS, TGS, and TGT, those are actually going to be KDCs. KDC, or on the KDC. The KDC is the Key Distribution Center for Kerberos, and the Key Distribution Center for Kerberos that grants these ticket granting tickets, which is actually the authentication server, is actually in a Microsoft network, a Microsoft Active Directory server, right? Just to simplify it, it's just the Active Directory server. It does all those Kerberos roles. And what it's going to do is when the authentication server, the user sends a request. Hey, I'm looking to do some work on this network. Here are my credentials, the authentication server. The authentication server is going to take a hash of that information, check it out, and then if it checks out, send a TGT, a ticket granting ticket, to the client. That ticket granting ticket has a lot of information in it, and you can only get the TGT if you're authenticated. And then once you're authenticated, and you have a service ticket, you can begin to interact with services on the network. Like for instance, let's just zoom out and see how this actually looks in real life. I come into my office at 7:30 a.m. I put my backpack down. I sit at my terminal. I do a Control-Alt-Delete. I put in my username and password, pull out my card and stick it in a slot, and I get logged in. That's how it all looks. But in the background, I was granted a ticket granting ticket, and now guess what I do? I'm going to say, all right, I was working on a document late last night. I'm ready. I'm just going to check it real quick, and then I'm going to print it. So I click in Microsoft Word, and I click print. When I do that, my ticket granting ticket is going to be presented to the resource, which is the printer, and say, hey, resource, I need a ticket so I can make use of you. And the resource is going to check my ticket granting ticket. And if it matches, the resource is actually going to decrypt the granted ticket, decrypt that ticket, confirm the identity, and allow me access to the printer. That's what happens in the end. So there's a lot more to these protocols than what we're looking at, but that's just a little look at Kerberos, the next protocol is pretty good privacy. And you know what? It's pretty good. So what pretty good privacy is, it's therefore cryptographic privacy. Back in the old days, people used to use PGP specifically and especially for email. There are other reasons people use PGP, but if you look at the way PGP was used, what would happen is this is part of a PKI. PKI is a public key infrastructure. Public key infrastructure, there is a public key and a private key. The public key is usually used to encrypt messages, and the private key is protected because it's private, and it's used to decrypt the message. So what people using PGP would do is put their PGP key in their emails as a tag, or they would publish it in other places. So you always had the capability to use their public key to encrypt a message and send it back to them, right? So that I would get an email from somebody perhaps, and on the email it would have the PGP public key that would allow me to use PGP to encrypt a message, send it back to them. When they got the message, it went over the internet, and if someone intercepted it, it was encrypted, so you couldn't do anything with it. But when they receive the message, they can use their private key to decrypt the messages. And so you see here that it's encrypted with the user's public key in the header, and when it's decrypted, it's with that private key, right? So that's asymmetric encryption. We'll talk more about that. The next one we have is SMIME. SMIME is a little bit more complicated than PGP. It's a secure multipurpose internet mail extension is what it stands for. And it's for sending not just encrypted message, but digitally signed. Digitally signed. What does that mean? Digital signature ensures that nothing changes from source to destination. And encryption. So it does both using RSA, which is a public crypto system that you can use. It's an entire system. The next one is that network defenders, you and me, we have to enable SMIME. There's hardly any email system that I can think of that has it turned on automatically for your mailboxes in the organization. And this is how it looks. So we have Ellis and Bob. And so what's going to happen is there's a message that needs to be secured, and Alice is going to take her private key and digitally sign the message, and then it's going to be encrypted. Now, you see DES here. DES is a digital encryption system standard that was the standard a long time ago, but it's hacked, it's cracked, and so you would never want to use DES in reality. If you had to use a DES-related encryption, you'd use 3DES, where you take the message and you encrypt it thrice, 3 times. Right? So either way, what happens next is we use our RSA encryption, creating a secret key with the public key of Bob. So now we're using Bob's public key to finish the encryption of this message. And so if you look on the other end here, in order to decrypt this message, Bob gets his private key and decrypts it, and then he's able to check that signature and open the message. So again, even with SMIME, we're looking at asymmetric encryption being used, private keys and public keys. And there's a difference between SMIME, this is version 3, and the version of PGP that we see being used here is Open PGP, but there are many other versions of it. So we see that there's differences in the messaging format, certificate format, and I'm not going to go into each one of these technologies like we do in some of the higher level classes. We have different asymmetric encryption algorithms, but I will point this out, that you notice that DES is not the standard. It's at least triple DES with CBC and so on. There are dictature signature algorithms. Diffie-Hellman is a very important algorithm. It helps when you have symmetric keys where two parties need to have the same key, and you need to send that key over an insecure network, a copy of it, so that both parties can have it. Diffie-Hellman is a big deal for that, and same with DSS. Hashing algorithms, SHA-1. We have MIME encapsulation. That's different on each of these. We have MIME encapsulation of encrypted data. If you were to have a look, let's say that right now you could do this, open up another tab, and in that tab, type in Wikipedia PKCS7 or PKCS number or #7 and hit enter. What you'll find is that there are a lot of PKCSs, huge numbers of them. Some are discontinued, some are still in place. But all of those are part of a PKI. A PKI, public key crypto system, is made up of PKCSs. All right, so now we're going to look at a couple of secure protocols. This one is actually not in use. It's called SHTTP. SHTTP came out around the same time as HTTPS. If you have a browser and you have a secure lock on the upper left-hand corner of your browser, that means you're using HTTPS. SHTTP is usually not accepted. In fact, look down here. Not all web browsers service support for SHTTP because it was not decided. There were two major players back in the wars between HTTP and HTTPS, and those were Netscape and Microsoft. And they both chose HTTPS. And so HTTP went the way of the dinosaurs very, very quickly. One of the problems with SHTTP, if you look at the web machine, the client machine, and the server machine, is that we have unencrypted information that goes over that network. It doesn't take the entire channel and the handshake and encrypt it. So SHTTP, two things. Number one, it's hardly ever used. And number two, the reason why is because part of the communication is unencrypted. With HTTPS, though, everything is encrypted. And that is what I was talking about, where you see that lock on your browser indicating that you're using encrypted communication. So it encrypts everything, the entire handshake, all of it, usually using transport layer security. SSL used to be used, and in some places it might still be used, but mainly TLS is used for it. It's often used in, often, I would say always, when you're on a browser, you see that lock, you're using HTTPS. And if somebody is trying to sniff network traffic, like for instance, you could be on a network, you could be using Wi-Fi on that network. With Wi-Fi, it's easy for an attacker to sniff the traffic. And guess what they'll see? Nothing. I mean, they'll see the communication, but they won't see any of the actual data. So TLS is the main type of security that's used in HTTPS. HTTPS is what happens when you go to that browser, you click on a link, and you get that lock. That means that everything between you and that resource is going to be encrypted. So that's what we find with TLS between client-server applications. It's used in other locations. TLS has both a record protocol for connectivity for your encryption, and it has a handshake protocol for authentication, to assure authentication. And so here we see two applications communicating with each other. We see the TLS stack, the stack of protocols. We see the handshake protocol, the record protocol, and then the transport is over the TCP/IP stack, which is an entire ball of information right there. And then the network hardware that handles the communication. In this case, it's going to be a NIC, a network interface card, like a Wi-Fi NIC or a wired NIC that's going to be communicating over the network. So that's TLS in a nutshell. And then SSL, which is secure sockets layer, still used for many different purposes. It makes use of good old RSA, which is asymmetric, meaning that there is a public key and a private key, whereas symmetric encryption, the keys are the same. And so you have to use a key exchange protocol like Diffie-Hellman to get them across. But this is an asymmetric protocol, meaning that somebody has a public key and another person has a private key, starting off a little hello message, And what's going to happen is there's going to be a little negotiation. Hey, what protocol can you use? Hey, what version do you have? Trying to determine encryption algorithms, session keys, compression, all that kind of stuff. And then they're going to determine that. And then finally, it's going to say, great, now that we can talk, hello, right? If you went, it's like going to a foreign country and meeting someone and they say something in the language and you say, I don't do that. Do you speak English? And they, no English. And you say, hablas español? And they say, no español. And you say, and then finally, oh, hey, let's all speak in whatever language. You decide to speak in Tagalog. So then you're communicating. All right, now that you speak Tagalog and I speak Tagalog, let's just say hello to each other, right? And that's what they're doing here. They've figured out how to talk. And then number 3, the server sends a nice hello message. And then we verify that we have the appropriate encryption. Public key exchange goes on. We send a challenge. This is where there's a finished message after the challenge is up. And then number 6, we calculate hash values, we exchange messages, etc. Eventually, at the end of number 6, guess what we have? We have a secure, I can almost get that out, secure communication channel between the two, right? So all that happens. How long does that take? It took me like about 2.3 minutes to talk about this, but it's going to happen in anywhere from 60 to maybe 120 milliseconds way before a second is even taking place. That happens when you start that SSL communication. Very quick handshake, very cool stuff. The next thing we talk about is IPsec or IPsec. IPsec is really cool. One of the things you'll find about IPsec is it forms the basis of a lot of virtual private networks. You know what I mean? A VPN. So like on your phone or on your tablet or on your desktop or on your laptop, you might communicate with a VPN. If you ever travel, oh my goodness, you need a VPN to try to make sure that your communication is encrypted if you use public networks at all, which I try to avoid. But sometimes you can't. And that VPN is so helpful to encrypt everything. IPsec forms the core of many VPN connections. But IPsec or IPsec is also very nice for communication between devices on the network. So if you go back into XYZ Corp, go to that first floor where the IT department is, and you go inside the data center, and you have inside all these racks, you have servers. They could actually be communicating with each other through IPsec, through IPsec, and it could be completely encrypted between every single server in the data center. You could even set it up between hosts and so on, but it gets a little bit crazy to administer. So it's end-to-end security, encryption, authentication, network level peer. So one device to another, authentication, authorization, integrity, confidentiality. IPsec can make use of a variety of protocols across its stack. For instance, just as one for instance, for encryption, it can use DES, 3DES, 2FISH, and many others, right? I mean, any of the most popular encryption protocols you can find on IPsec. And then different authentication, different hashing, all kinds of stuff. Anyway, I could go on and on about IPsec. I could go on and on about protocols that devices use to secure themselves, but we've come to the end of this module. So we looked at the different essentials in network security, making sure that we have the goal of network defense, information assurance. We looked at benefits and challenges of network defense. And I'll tell you what, we just touched the surface of the challenges. I'll tell you what, attacks are happening right now everywhere. We'll talk about those as we go on. It's also, we looked at different types of network defense approaches to security controls. And finally, we looked at several different network security protocols, stuff that's used to secure transactions for email and for communication between devices. And so guess what we're going to do in the next module? We're going to look at identification, authorization, and authentication And that's the end of that. So join me in the next module.